In your previous classes, you have learned about Newton's second law and the definition of momentum and the related topics. In our class, we are going to learn about the law of conservation of momentum. Here, we see two pebbles with masses m1 and m2. Actually, consider the force is applied on these two pebbles. After applying the force, they were in the motion. Now let us consider the situation. Here, they were in the motion with the initial velocities u1 and u2 respectively. That is the mass m1 with u1 and the mass m2 with u2 are moving in the rectilinear path like this. Let us suppose u1 is greater than u2. So that means the mass m1 is moving with a large velocity, high velocity than the object m2. What happens after moving in this direction? After some time, some duration of the time, they collide with each other. That is common. So they come into contact or they interact. Then what happens? The mass m1 exerts force on m2, and in turn, according to the Newton's third law, the m2 also exerts the same amount of force on m1 but in the opposite direction. Let us suppose m1 2, that is the force applied by pebble 1. Let us suppose it is pebble 1 and it is pebble 2. The F1 2 indicates the force applied by the pebble 1 on pebble 2 is F1 2, and in turn the second pebble exerts the same amount of force on the pebble 1 but in the opposite direction, that is F21. According to the Newton's third law, F12 is equals minus F21. Okay, after the collision, they continue the rectilinear path like this. So this is the situation. Then let us see how the momentum is changed. Here we write the parameters in a tabular form. Let us suppose it is pebble 1. This is pebble 2. Masses. M1 has pebble 1 has m1 mass and pebble 2 is m2. Initial velocity of pebble 1 is u1 and pebble 2 is u2. Then initial momentum. The momentum is defined as the product of mass and velocity. Initial momentum, that is m1 u1. For pebble 2, this is m2 u2. So after the collision, this is the situation before the collision. After the collision, they gained the velocity v1 and v2 respectively. So final momentum, I am writing directly, mass is m1 and the velocity is v1, then momentum will be m1 v1 and m2 v2. Now let us write the change in the momentum. The change in the momentum, the initial momentum, this is the final momentum. The change can be calculated as m1 v1 1 minus m1 u1, m1 v1 minus m1 u1. Here also, for table 2 also, the change in the momentum can be calculated like m2 v2 minus m2 u2. Now, with respect to the time, that is the collision time, that is the impact time, the interaction time, let us take as t. For the time period t, they were in the collision. Then the rate of change of momentum of these two bodies can be calculated as m1 v1 minus m1 u1 by time period t. m2 v2 minus m2 u2 by time period. Let us separate with it like this. Okay. The rate of change of momentum, that is the change of momentum, can be shown as delta p. Then this is delta p by delta t. Okay. So during this collision, we have observed that F12 and F21 both are equal and in opposite direction. So according to the Newton third law, F12 is equal to minus F21. According to the Newton's second law, the F net or the force is nothing but the rate of change of momentum. The rate of change of momentum. So here F12, this is F12, this is F21. Then from 1 and 2, this is according to the Newton's second law. Now write down the values. That is F12, m1 v1 minus m1 u1 by t is equals minus of m2 v2 minus m2 u2 by t. Both the sides t gets cancelled. Here m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. Write down this. m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. This can be written as m1 v1, this minus m2 v2, when it comes this side, it becomes plus m2 v2 is equals m2 u2 plus this minus m1 u1 becomes plus m1 u1. So from this, the final equation is like, so I will adjust here, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the final equation. Let us elaborate this. What does it explains? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That tells us that this is the sum of the momentum before collision. This is the sum of the momentum after collision. So it is clear that before collision and after collision, the momentum is stable. It is unchanged. In other terms, we can say that in a collision of objects, the momentum remains unchanged. The momentum is conserved. So this is the law of conservation of momentum. Okay children, we have completed the lesson. Let us see what we have learned so far. If the board is not visible, here we can note down the points. Yes, this is the final formula that we have derived. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Now let us see some videos which involve the law of conservation. So far you have learned law of conservation of momentum. Now let us see a fun activity in which the law of conservation of momentum is involved. That is the application of law of conservation of momentum. Let us see the video. All of you watch the video carefully, and we'll see how the law of conservation of momentum is involved in this fun activity. Okay?
1, 2, 3, 4, 5, 6, 7.
Right. Students, have you enjoyed the activity? Have you enjoyed the video? I think so. Let us see how this law of conservation of momentum is involved. The first, there were 7 coins. Yes. 2, 3, 4, 5, 6 and 7 coins were taken in this activity. If we take one away like this, let us take it to halves of the board. This is before the collision. This is after the collision. So let us try to calculate the total momentum of this system before collision and after the collision. See, before the collision it was like this. This was hit the 6 coins. The initial velocity of this particular coin is, let us say, suppose V. The remaining 6 were at rest. So let us say V1 and V2. V1, that is the velocity of this coin with which it was traveling in this way, and it was hit this remaining 6 coins. All they were at rest. Let us suppose the mass of each coin is m. All are of equal masses. So this is m. 1, 2, 3, 4, 5, 6 m. Understand? Each are of equal masses. Let us say it as m. Then what will be the momentum? So V1 m plus V2 is 0 into 6 m. That is called v1 m. Let us say the velocity of the coin as v. Instead of v2, it is v. Doesn't make any difference. For convenience only we have taken it as vm. This is the total momentum of this 7 coin system before the collision. After the collision, what happens? So the last coin was separated. The first one is attached to the system. So 6 remains and 1 is thrown away. Now what happens this? So all the 6 were at rest. V is equal to 0 of the system. Let us say the velocity of the one coin, remaining coin is m. Automatically, what would be the mass? 6m is the mass. Here it is single m. Now calculate the total mass of the system after the collision. That is equal to momentum is the product of mass and velocity. Mass is 6m, velocity is 0, plus mass is m and velocity is v. Then it is 0 and this is mv. That is nothing but mv. See, before the collision, the total momentum of the system is mv. After the collision, the total momentum of the system is unchanged and conserved. So this fun game, in this way we have learned about the conservation of the momentum. Now let us watch some more videos. Okay?
Impulse of a force. In case of a ball hit by a bat or driving a nail into the wooden block with a hammer, the force acts for a short time interval. This force varies with time, hence cannot be measured easily. In such cases, we measure the total effect of the force called as impulse of force. Consider an impulsive force vector F acting on a body of mass m for short time t. The velocity of the body changes from vector u to vector v. According to Newton's second law, vector F is equal to vector p2 minus vector p1 upon t. Impulse of the force or impulse vector F dot t is equal to vector p2 minus vector p1 that equals to vector j that equals to m vector v minus m vector u. This shows that impulse is equal to the change in linear momentum of the body. Impulse is a vector quantity. Its direction is same as that of the force. The SI unit of impulse is same as that of linear momentum, that is kg meters per second or Newton.
Now we are going to learn one more important concept, that is impulse of force. Okay students, I know most of you like the game of cricket. Of course, most of you like to play the cricket whenever you get a free time. So you might have observed how the batsman hit the ball. When the ball is thrown towards the batsman it takes the bat up to some extent back and hits the ball like this. Then what happens in this case? Have you noticed the force that transferred from through the hands and through the bat to the ball? In this case, a huge amount of force is applied on the ball for a very small amount of small duration of time. Yes, the condition, a big amount of force is exerted on the ball for a shorter and shorter duration. Okay, yes, this is the one instance that we have observed. The another one is in our house or somewhere else, we used to hit the nail with the help of a hammer. How we hit? So we take a nail and like this with one stroke, we used to hit the nail into the wall or into the wooden block. Here also what happens? A huge amount of force is exerted on the nail for a very short time. This is called the impulse of force. What happens? Impulse. So, in this case of impulse of force, we can observe clearly a change in the momentum of the body. So, the impulse of a force indicates the degree of the momentum or the change in the momentum of a body. Actually, it is not the character of the body. Rather, it tells us the characteristic or the intensity of another character of the object. That is the momentum of the body. How large the change in the momentum taken place when a certain amount of force is exerted on a body. So this is what about the impulse of a force. Now let us try to derive a formula for impulse. For that we have to recall the formula that we have learned while learning the Newton's second law. According to the Newton's second law, the formula is like the F net is equal to the rate of change of momentum. So this is the delta P indicates the change of momentum, delta T indicates the interaction period, the duration of the period in which the two objects interacted or the amount of force, amount of momentum is exchanged is denoted by delta T. F net denotes the force, net force. So this is the formula. Then the impulse of body, the equation can be written as delta P is equal to F net into delta T. This is the formula for the impulse of a force or impulse simply. So how can we define the impulse in another type? So one type of definition is like what is impulse? A force exerted on a body for a very short time is known as impulse. In other words, the impulse can be defined as the net force acting on a body and the change in the time, the interaction time, the product of F net and the duration of the interaction is known as the impulse. Okay, this is the formula for the impulse. In some books it can be denoted by J. J is the impulse. J is equal to F net into delta T, where delta P or J is the change in the momentum. That is why according to this formula also we can define the impulse as a change in the momentum. What does it mean? Change in the momentum, initial momentum and final momentum. So the change in the momentum can be defined as the difference of final momentum minus initial momentum. Let us say the mass of a body is m. This is the mass is equal to m. Initial velocity is u. Final velocity of the body is equal to v. Then the change in the momentum can be defined as that is denoted by delta P is equal to mv minus mu or m into v minus u. In this case, the impulse can be written as m into v minus u is equal to f into delta t. F, actually it is f net. This is also another formula for the impulse. Yes, impulse is nothing but the characteristic which denotes the amount of change that occurs in the linear momentum of the system due to the external force, the force exerted on the system. So with the help of this, what happens if impulse happens in a system? Actually, what happens in this case, the impact of the force will be very high. The impact of the force will be very high during the impulse. So when we hit the nail with the help of a hammer, what happens? The impact of the force becomes big and big. Then the nail get into the wall. In the same way, with the impact, high impact of the force of the bat, the ball goes away and even crosses the boundary line. So in this case, in the game of cricket, also you might have observed when a fielder catches the ball, then what he does? It is also your common experience. When we are trying to catch a ball in cricket, then we take back the hands with the ball up to some distance. Up to some distance like this. Otherwise, what happens? If you catch the ball without taking back your hands, what happens? It will pain your hands. Really, the ball will give you a huge amount of pain. In the same way, in the game of pole vault or running or jumping, what happens? After jumping in the pole vault, the athlete falls on a cushioned surface rather than the concrete surface. What happens if it is a concrete surface? The athlete may break his legs or get some pain. So in all these cases, what happens? Okay, now let us try to see how to reduce the impulse. Impulse sometimes gives us a kind of pain that we have learned. or also impulse sometimes gives us a huge damage. In the case of in the case of accident, a car hits the wall or a car hits a lorry. In that case, a large amount of impulse takes place. It damages, even sometimes it may leads to death also. So we have to reduce it. We have to reduce the impulse. Then what are the ways? Let us see what are the ways to reduce the impulse. Okay. As per the definition of the impulse, that is the delta P is equal to F net into delta T, or F net is equal to delta P by delta T. Okay, this is the impulse. This is the force exerted on the body for the short duration. See, here F net is equal to delta P by delta T. In order to decrease the impact of the force, that is F net, what we have to do? We have two chances, two options actually. One is we can decrease the delta P, that is the change in the momentum. Change in the momentum, how can we decrease it? How can we decrease the change in the momentum? That is delta P, that is equal to m into delta V. M is constant, that is the mass of the body is always constant. So the change in the velocity leads to the change in the momentum. So we have to decrease the momentum, means we have to decrease the velocity of the body. So this is one way. So during the accident or during something else, we cannot decrease the velocity. What we can do? So we can increase the impact time. If we increase the impact time or interaction time, then automatically the F net will be decreased. What is our intention? We have to decrease the force acting on the body during the collision or something else. That is our motto. Our aim is to decrease the F net. To decrease the F net, there are two ways. One is decrease the change in the momentum and increasing the interaction time. So where to decrease the F net, we have to increase the duration time of impact, or decrease the change in the momentum. There are two ways for us. So in the video that you have seen, what happens? A cricketer, while catching a ball, what he does? So he takes back his hands with the ball up to some time, some duration of the time. So what he doing while taking back his hands with the ball? So he is increasing the impact time, that is the impact of the ball, impact of the speeding ball on the hands. So he is increasing the duration of the traveling time. Otherwise, what happens if he, here for example, the ball is coming towards me. For example, I try to catch the ball like this. What happens? It hits me, the impact will be very high. The impact of the force will be very high, and it will definitely give a pain. Then what I do to avoid that pain? So I just takes back my hands along with the ball up to some extent by increasing the traveling time. What happens when I increase the impact time or the duration of the time? Automatically the net force will be decreased. That means the impulse can be decreased. This is one example for that. It is also we may see some more examples in our day-to-day life. In cars, nowadays in cars, there are so many safety measures to save the lives of so many people. So nowadays the cars are coming with airbags. What does the airbags do? During an accident, that is high amount of force, the airbags in a collision automatically they gets opened. Then the traveling time of the collision will be increased. Automatically the impact of the force can be decreased. So this is how the airbags can save us from big accidents, from injuries, or some in some cases death also. So this is the application of the impulse and how to decrease the effect of the impulse. Okay student, here is the problem. A hammer of mass 400 grams moving at 30 meters per second strikes a nail. The nail stops the hammer in a very short time of 0.1 seconds. What is the... Okay children, so far we have learned about the law of conservation of momentum and the impulse of force, and how we can reduce the impact of the impulse. Now let us try to do some problems. Okay, let us see the first problem. Okay, this is the first problem. What it says: hammer is 400 kgs. It is given that the mass of the hammer let us say that is M is equal to 400 grams. That is nothing but in MKS we have to measure it in kilograms. That is why it is converted into kgs. Then it becomes 0.4 or 0.4 kgs. The velocity of the hammer was moving with the velocity at 30 meters per second. It is given that the initial velocity of the hammer let us say it as u is equal to 30 meters per second. When the hammer touches the nail, it becomes, the velocity becomes 0. Then the velocity of the hammer becomes 0. That is the final velocity of hammer, that is v is equal to 0. Then what would be the change in the velocity? That is delta v. Delta v is equal to u minus v, that is a change. It is equal to 30 minus 0 is equal to 30 meter per second. That is the change in the velocity. Okay. Now the duration of the impact, that the duration of the impact, it is given that is delta t is equal to, it is given as 0.1 second. Actually it is 0.1 second. Then we have to find out the force exerted by the nail on the hammer to stop its momentum, stop its motion. That is, we have to find out f net. How much f net? So while solving the problems like verbal problems, we have to first write the steps like this. What are given? What is to be found? So what are given? M is given, the change in velocity is given, the time duration is given. We have to find out f net. Then we have to look to what really links between the given values and the value to be found. So that is a relation. What is the relation between f and all these things? Automatically the Newton seconds law comes to our mind. That is f net is equal to delta p by delta t. In other words, what is delta p? That is m into delta v by delta t. So with the help of this formula, we have to find out f net. So it is equal to, substituting the values, what is m? And 4 into, what is delta v? It is 30 by, what is delta t? Impact time, that is 0.01. So solving this 12.0 by 0.01. Then two decimals we have to increase, then we'll get 1200 newtons. So in this case, the nail requires the force is 1200 to stop the hammer. So this is the, here is the problem number 2. Note down it and let us solve the problem. Okay children, you have seen the problem number 2. Now let us find out the solution. Let us try to solve it. So the problem is like a car of weight 3600 kg. It is moving with the initial speed of 100 km per hours, and it collides head on with a wall for a shorter duration of 0.1 seconds. The collision took place. Then we have to find out the impulse of the collision. That is the impulse of the wall exerted on the car. Now let us find out. First step is what are given. The mass of the car. The mass of car, that is let us say m is equal to 3600 kg. And the speed of the car also given, the initial speed, that is initial velocity actually, in a linear momentum there is no change at all between velocity and speed. Initial velocity, let us say u, it is given 100 kilometers per hour. We have to convert it into the meter per second. So for that we have to multiply with 5 by 18, then (500 by 18), then with 2 we can strike it out, 250 and 2 9s, then it becomes 250 by 9, that is u. So after hitting the wall, the car comes to rest, that is the final velocity of the car is 0. Let us say v 0, then change in the velocity, that is, let us say as v, that is v minus u is equal to 0 minus 250 by 9, that is minus 250 by 9. Okay, note this minus also, it is there. I will tell you the importance. Now time duration, the time of impact of the impulse or force, that is 0.10 second. Actually it is given, that is 10 is nothing but 1 second, 0.1 second. We have to find out the impact of the force of the ball on the car, that is F net. How much it is? As we solved earlier problem, the formula here also is the same, that is F net is equal to delta P by delta T, that is nothing but M into delta V by delta T. So substituting the values, M is nothing but 3600 into delta V is minus 250 by 9 by 0.1. So minus comes first, 3 by 9 into 0.1. 9 ones are 9 fours, that is 400. So how much it is? 25 to 4, that is 100. It is minus 1, 2. 25 to 4 is 100. Then 1, 2, 3 zeros. 1, 2, 3 zeros by 0.1. Then one more zero will come in the numerator. 1, 2, 3, 4, 5, 6. That is equals minus 10 rises to 6 newtons. The minus indicates the force on the car, that of the collision. So here we have make use of the Newton seconds law, that is F net is equal to delta P by delta T. Like this we can solve the problems. So we come to the end of this lesson. In this lesson, let us recall what we have learned. So starting with Newton's first law, which deals with inertia, and Newton's second law, which deals with the momentum of the system or body, and third law, action reaction frame, and of course impulse and the factors that we can reduce the impulse, and of course the problems. Okay students, this is very important topic in your higher studies or in your higher classes also. These concepts are very useful. Hope you all enjoyed well.